Hey there, Sea-Ho Mariners. I want to go over how we analyze polynomial graphs. This is topic 4b. This is a little bit more detailed oriented, and we use a lot of the vocabulary that you saw on the Learning Goals page. So we're going to be talking about maximums and minimums, inflection points, increasing, decreasing behavior, concave up, concave down. The first thing we do is I like plotting all the critical points. So that's maximums, minimums, x-intercepts, and we'll talk about points of inflection in just a little bit. But we read these graphs from left to right. So if we look at this graph, we're going this way. And I'm going to first put points where my critical points are, just to help me identify when we go through all the details. So when you do analyzing polynomial graphs, the first thing is I hope you understand how to describe the polynomial. So we have a third degree polynomial with a leading coefficient of 1 and a constant term of 3. And that makes sense. There's my y-intercept. Now the first thing we do is, after we put all our points on our critical points, I like to do this first. Identify increasing and decreasing behavior. Now we're going to be reading along the x-axis. So what makes this part of the skill difficult is sometimes we're looking just at the x-axis, and sometimes we need to write ordered pairs. So the maximum points, the minimum points, and the inflection point or points all have to be written in ordered pair form. And the rest of these we're using interval notation. So when we look at a polynomial graph going from left to right, we're looking for where the graph is increasing. So this graph increases from negative infinity all the way up to there. And then it increases again from 2 all the way up to positive infinity. But it decreases from x equals 0 all the way to x equals 2. So this helps us not only with our maximum and minimum points, but also helps us with writing our interval notation. So for increasing behavior, we're going from negative infinity, and we're going to 0. Now we keep it as parentheses because that 0 is being shared by something else. And then it's also increasing from 2 to infinity. And then whenever we have two interval notations that we need to include, we combine it with the mathematical symbol for conjunction, is the U. U stands for union. So whenever we have to combine two intervals, we use the U. Now the decreasing behavior starts at 0 and it goes to 2. Again, we're using parentheses. We're not using the square brackets. Using parentheses. Now the reason why we do increasing decreasing first is so that we can get our maximum and min points second. Now in polynomial world we have these things called absolute maximums, absolute and local max and mins. Now, absolute means the highest point on the graph, and local just means the next highest or the next lowest. So in this particular graph, since it goes off into infinity in the positive direction and infinity in the negative direction, there are no absolute maximum and minimum points. But we do have a local point, a local max right here. It's the next highest. And we have a local min right here, which is the next lowest. And then we report those as ordered pairs. So the local max is at 0, 3, and the local minimum, as you can see, 2, negative 1. Okay, first two out of the way. Now the third thing we look at is our concavity. Okay, concave up is like a positive parabola. It's a U shape. It holds water. Concave down is like a negative parabola where we're going downwards. So what we need to do is identify where things are concave up and where things are concave down. So it's concave down, if we look at this, from here and then somewhere in between that maximum point and that minimum point, concavity changes. Concavity changes to concave up. And it's concave up all the way to infinity. Now this part right here, this little area, actually it's just a point, where it changes concavity, where it switches from a concave down to concave up or vice versa, this is called point of inflection. Now some graphs have 1, some have 2, some have 3, and in topic 5 you're going to figure out how many points of inflection a graph will have just based on the degree, because they all have this similar behavior. So to find that point of inflection, I just want you to estimate, and it's in between the two max and the min, so it's between 0, 3 and 2, 1. So along the x, it's got to be right around 1. And then from 0 to 3, it's got to be somewhere like 1.5. So I'm going to just estimate this as 1, 1.5. Just a guesstimate. And some of these will be a little bit more accurate because they'll fall right on a grid line, but sometimes you just have to find the average of the x's and the average of the y's to get your point of inflection. So that's, again, we'll write as an ordered pair, 1, 1.5. And there's only one point of inflection. So let's take a look at a different type of a graph, and we're going to follow these same 3 steps, because concavity, actually I should write, this gives you point or points of inflection. So if you can identify the concavity, you can figure out the points of inflection. So let's take a look at this graph. Holy cow. So this is a degree 4 polynomial. It's got 3 100ths or 0.03 as its leading coefficient with a constant term of -2. And look at that, there's the y-intercept. So I'm going to first put dots again where I see my critical points. We'll get to the points of inflection in just a little bit, again, after the concavity. So the first thing we're going to do, again, we're reading this left to right along the x. Along x. Okay. So we're going to do increasing, decreasing first. So it looks like I'm change my color, let's keep it consistent. Looks like I'm decreasing first. I'm decreasing all the way to here, and then I'm increasing to there, and I'm decreasing a little bit here. Oh, I didn't put that point there. Oops. And then I am increasing the rest of the way. So I've got 2 places where I'm decreasing, 2 places where I'm increasing. So increasing first, so it looks like I'm increasing, that looks like, oh, I don't know, negative 1.75 to 2. And since I'm increasing a second time, I need to have that union there. And this one's a little bit easier. 4 to infinity. Now it's decreasing. Again, left to right, reading it left to right. It's decreasing from negative infinity to where I started increasing, which is negative 1.75. So negative infinity and I'm decreasing again. This one's a little bit easier, from 2 to 4. And notice how these line up. So negative 1.75, negative 1.75, and then 4, 4. Okay, so there's a little bit of overlap, and you can check your work, because an increasing behavior, especially if you have a graph such as this, an increasing behavior is going to be followed up with a decreasing behavior, and then follow up with an increasing behavior, and then same thing here. Okay, all right, so now let's take care of our maximum and minimums, since we know where we're increasing and decreasing. So here's number 2. So I've got a, notice that the graph goes off to infinity here. So there's no absolute maximums here, but it does go to the lowest point on the graph, right here. So I've got an absolute minimum. So I've got an absolute minimum at, and I just have to identify the point. It looks like we're at negative 1.75, negative 4. Negative 1.75 and negative 4. And we also have, so here's our absolute minimum. We also have a local minimum. So it's the next lowest point. So this is the biggest, or the lowest point, and that's the next lowest point. And that one we'll just call, so this is our local min, and that looks like it's at 4, negative 1. And then, since we don't have an absolute maximum, we have a local maximum, a local max. Okay, it's a high point on the graph, but it's not the highest point on the graph. So local will have to be at 2, 0. Okay. So we have an absolute minimum and a local minimum and a local maximum. Now we do our concavity. Our concavity is going to help us with our point or points of inflection in this case. So let me change back to color I was using. So it looks like I am going to be, what did I use up here? I used pink. Looks like I am concave up all the way probably to between somewhere right around there. And then I'm concave down to about right there. And then halfway in between, I am concave up again all the way to the end. So my point of inflection, I'm going to call it right there, and I'm going to call it right about there for concavity. So I have 2 points of inflections because I've got a concave up, then a concave down. Oops, don't know what happened there. And then another concave up. So we write it as ordered pair. The first point of inflection going left to right looks like we're at 0, negative 2. And the second point of inflection looks like a little bit more than 3 and a little bit less than negative 1. So we'll call it 3 1/4 and I don't know, what, negative 0.75. Again, these are estimates, so it's a point. And then concavity, left to right, concave up, it looks like we're going from negative infinity to our point of inflection, which happens at 0, -2, so we're at 0, again along the x, union, concave up again, so it looks like 3.25, again it's along the x, and all the way up to infinity. And we are concave down from, looks like 0 to 3.25. Again, this is along the x-axis. We're reading along the x, so it's turned downwards from 0 to about 3.25. So that's how we analyze a graph. And it can get pretty tricky, especially if you're mixing up your ordered pairs with your interval notation. So come back to this time and time again if you need to, but we'll go over some examples in class, and there's plenty of practice. Okay, till next time, see you home. See you later.